The deeper I study Mars, the more terrifying it seems, because there are countless bizarre and inexplicable landforms on Mars, scattered across its surface. One of the most striking among them is a square-shaped structure captured by the Mars Global Surveyor's orbital camera. This image is included in the Mars Image Explorer, developed by Arizona State University. It is completely public, anyone can look it up online, but it is precisely this almost unnaturally regular structure that, since its exposure, has sparked intense debate among scientists and Mars researchers. Some say it is a kind of peculiar wind-eroded remnant. Others firmly believe behind this geometric landform lies a secret far beyond geological activity, because on the chaotic and rugged surface of Mars, such a symmetrical and sharply defined square structure is simply too conspicuous. Nature rarely produces such regular shapes, because geological processes like wind, water, and volcanoes usually create chaos and disorder. It is almost impossible to precisely outline such regular boundaries. It is exactly this sense of discordance that has made it a source of suspicion and speculation. Some researchers have even suggested that this geometric precision is very likely not naturally formed, but rather a trace of some intelligent design. They boldly hypothesize Mars may have once possessed a highly advanced civilization in the distant past, or perhaps it was briefly visited by extraterrestrial intelligent beings. This structure might be a fragment of some ancient architectural ruin, now half buried beneath dust and sand, with only its broken edges remaining, waiting to be rediscovered. What is even more intriguing is that this structure is not only oddly shaped, its size also far exceeds that of ordinary rock formations. Precise measurements from orbital images show it stands out distinctly from the surrounding terrain. It seems out of place here, with no reasonable natural comparison. If it really is a natural phenomenon, then there should be more similar formations in the surrounding area for comparison, but in reality, it stands alone on the Martian surface. No companions, no source. This uniqueness only adds to its sense of mystery. Scholars who support the artificial structure hypothesis believe that this landform might be like the ancient ruins on Earth, evidence left behind by an ancient civilization. If Mars once had an atmosphere, flowing water, and a stable temperature, it could have nurtured life and developed society. It is not just a fantasy. A massive climate catastrophe, planetary orbit shift, or other unknown factors could very likely have ended it all. Only scattered remnants remain, waiting for future generations to discover and interpret. There is also an even stranger, yet not entirely dismissible possibility. This square structure is a base or relic of some non-human civilization. Its symmetry and regular edges, it looks like it was deliberately constructed rather than formed naturally. If that is true, then our previous understanding of Mars has been far too superficial. Even our knowledge of the entire solar system might need to be fundamentally rewritten. Of course, NASA and other space agencies have always taken a cautious, even evasive, attitude toward this. These kinds of structures are generally classified as imaging errors or ordinary geological phenomena, but these explanations have not stopped a large number of independent researchers and image analysts from continuing to track these anomalous landforms. As more high-resolution images are sent back, the number of these anomalous landforms has only increased. This forces us to reconsider whether Mars is really as dead and lifeless as we thought. To get to the bottom of this, let us dive deep into Mars together. We are searching for some clues. You are the first human explorer to set foot on Mars. Your top priority is to venture into Jezero crater. The red, rusty dust is as thick as fog. You carefully feel your way forward, step by step. Suddenly, you trip over something. Almost tripped. You bend down and see something that looks like a skull staring right at you. Whose remains are these? A Martian dinosaur or a lost civilization? Martian dinosaur or lost civilization? Do not worry. This is not a sci-fi plot. If the Perseverance rover could talk, it would tell you that is just a weirdly shaped rock. But it is enough to send chills down your spine. Since December 2024, Perseverance has been descending the steep slopes of Witch Hazel Ridge to explore the edge of Jezero crater. Scientists speculate that billions of years ago, it was a lake that may have nurtured microorganisms. April 11th, 2025, the rover discovered a jet black, sharp boulder at the junction of light and dark rock layers. It was later named Skull Rock. It is astonishingly dark, covered with dense holes. People with trypophobia would get goosebumps just looking at it. NASA immediately announced on its blog, Skull Rock is completely different from the surrounding rocks. It is located in the N-Port area, a region where most of the rocks have drifted in. These are called erratics. Back when Mars was still warm and wet, with rivers and lakes crisscrossing the land, water carried these materials here. As the water dried up, the soft soil eroded away, leaving only the harder rocks exposed. But how did these holes form? One theory suggests that rock particles flaked off over time, leaving behind pits. Another theory proposes that Mars is strong. Sand-laden winds acted like sandpaper formed by long-term nighttime erosion. The Skull Hill is very dark in color and was initially suspected to be a meteorite, but Perseverance's super camera ruled this out after analyzing the chemical composition. The results show it is more like volcanic rock plus 0.2 EV. The dark color comes from minerals like olivine, clinopyroxene, and biotite. It is either the remnant core left after ancient lava flows weathered away, or it was blasted to the surface by an asteroid impact that exposed underground volcanic rock. The reason we can draw these conclusions is all thanks to Perseverance's versatile analysis toolkit. In just the past few months, it has collected 5 samples and closely studied 7 rocks. It has also used remote laser scanning on 83 rocks, setting a new record for workload in the past 4 years, according to GPL. In the past, finding a research-worthy rock in a crater, it could take months to find such rocks. Almost every few steps along the crater rim brings a new surprise. The biggest question is whether these samples can actually be brought back to Earth. The Mars sample return as a mission is technically complex, extremely costly, and has faced repeated delays. For now, these rocks can only remain on Mars temporarily, waiting for the day they can catch a ride home. Meanwhile, another rover is also quietly advancing another important mission. That is the Curiosity rover. It may have discovered a key clue that could help explain how Mars lost its atmosphere billions of years ago. Mars once had a thick, carbon dioxide-rich atmosphere. If the climate was warm and water was flowing back then, there should logically be large amounts of carbonate minerals left behind. These are formed when carbon dioxide reacts with water and rock. They should be deeply buried in the soil, but strangely, scientists can hardly find any trace of these carbonates. This has become a long-standing mystery in Mars research. But now there has been a breakthrough. A new study suggests that this missing carbon dioxide may not have just disappeared into thin air. Instead, it was hidden inside an iron carbonate mineral called siderite, and these minerals might be buried in some sulfur-rich rock layers on Mars. Because these rocks are hard to identify in orbital images, perhaps that is why humans have never really noticed their existence. Scientists speculate that at some point, Mars' carbon cycle may have gone wrong. The rocks absorbed far more carbon dioxide than they released. Over time, the carbon dioxide in the atmosphere was drained away. This directly caused Mars to start cooling down. The climate became dry and harsh. Eventually, it lost the ability to support life. In other words, Mars did not become cold overnight. It froze to death step by step, and right now, Curiosity is in Gale Crater. They discovered this kind of siderite rock layer. That area used to be the bottom of an ancient lake, full of moisture, and there is also a large amount of salt in the related rocks. Salt usually appears after a body of water dries up. All this evidence supports a key conclusion. Mars did indeed go from being a warm and wet planet to experiencing dramatic climate change, and that is how Mars ended up the way it is today. If we can find siderite in other regions of Mars in the future, we will basically be able to explain the entire process of Mars losing its atmosphere. More importantly, this would provide solid evidence for the hypothesis that Mars was once suitable for life. But Curiosity's discoveries do not stop there. It also carries a set of advanced scientific instruments called SAM, specifically designed to analyze the composition of Martian rocks and soil. Right in Gale Crater, SAM collected and analyzed some rock samples and found organic molecules. These molecules contain carbon, which is the foundation of all life on Earth, whether it is plants, animals, or humans. We are all carbon-based life forms, so this discovery is crucial. Mars not only has the environmental conditions needed for life, but now we have also found the raw materials for life. Even more intriguing is that SAM also discovered some unique distribution patterns in certain gay components, such as the arrangement of carbon dioxide and methane. These patterns are surprisingly similar to the traces produced when ancient microorganisms on Earth synthesized organic matter. Very similar. But does this mean that life really existed on Mars? For now, the answer is still inconclusive. There is another possibility. These organic molecules might have been produced by the reaction of the sun's ultraviolet light with Mars' atmosphere. Without any involvement of life, Mars lacks the protection of an ozone layer. Intense ultraviolet radiation can break apart atoms and rearrange molecules, then form new organic compounds, which settle to the surface with the dust. In other words, all of this could simply be the result of natural chemical reactions, but regardless of which explanation is correct, one thing is certain: Mars has the chemical prerequisites necessary for life. Speaking of this, sometimes I wonder, If Earth were ever struck by a disaster powerful enough to destroy civilization, humanity's only way out would be to leave our home planet. Which planet should we pin our hopes on? Most people's first reaction is usually Mars. It is close. It is a terrestrial planet, even has a thin atmosphere. It sounds more promising than Venus or Jupiter. But reality is far less ideal. The average temperature on Mars is about -62 degrees Celsius. The North Pole seems almost tropical by comparison. The radiation intensity on its surface is extremely high. It is enough to make any forbidden zone on Earth seem gentle and harmless by comparison. If you were to suddenly teleport to the surface of Mars without any protective gear, you would not freeze to death instantly. Instead, your blood would start to boil first. Your body tissues would break apart due to the pressure difference. This is not an exaggeration, it is basic physics. And this is exactly where the idea of terraforming Mars comes from. If we can technically achieve the transformation of Mars, can we really turn it into humanity's second home? First, we need to create a magnetic field for Mars. On Earth, it is the movement of the Earth's core that generates a global magnetosphere, protecting us from solar wind and ultraviolet radiation. But Mars lost its magnetic field billions of years ago. Since then, its atmosphere has been continuously stripped away by the sun. If we want Mars to become habitable again, we have to work on both its magnetosphere and atmosphere. Mars' atmosphere is almost entirely carbon dioxide, with only trace amounts of oxygen. To give Mars breathable air, we have to warm it up and make its atmosphere thicker. A key step to achieving this is to melt the ice. Currently, Mars' polar regions and some underground areas store large amounts of frozen carbon dioxide. If we can raise the surface temperature of Mars and let this dry ice sublimate into gas, we can artificially thicken Mars' atmosphere, further intensify the greenhouse effect to make the planet warmer, and possibly even create liquid water. Liquid water is the prerequisite for plants to survive and for life to reproduce. Scientists have already found traces of water beneath the polar regions of Mars. There are also large deposits of ice on the polar ice caps. On certain steep slopes and near volcanic craters, they have even found traces suspected to be left by brief flows of briny water. But because the atmospheric pressure is too low, most water can hardly remain in liquid form on the surface for long. So here's the question. How do we warm up Mars? Elon Musk once proposed a famous plan, detonating a large number of nuclear bombs above Mars to make it warmer. Of course, these nuclear explosions are not meant to destroy anything, but to continuously release thermal energy, vaporize the polar ice caps, to create an artificial greenhouse effect. It sounds like something out of a science fiction novel, but he believes it is a quick and effective way to heat things up. Aside from nuclear explosions, there are many more environmentally friendly proposals. For example, using giant mirrors to focus sunlight onto Mars' polar regions, or redirecting asteroids to crash into the ice caps, trigger a temperature rise using impact energy. Some have even suggested producing artificial greenhouse gases on Mars, such as fluorides, but without exception. All these proposals have a fatal flaw. The cost is ridiculously high. The technical threshold is almost impossible to reach. Is there a more realistic approach? At this point, we need to mention a key figure, Handemer. He once worked at NASA's Jet Propulsion Laboratory, and now has founded a startup company with the goal of developing carbon-negative natural gas. He has also proposed a terraforming Mars plan that would cost only $1 billion. His core idea is to use solar sails to heat Mars. These solar sails are space devices that can be mass-produced on a large scale. Each solar sail is a small satellite, propelled by the pressure of sunlight. It's like a sailboat moves with the wind. Handemer's idea is to launch tens of thousands of solar sails from Earth's orbit, let them automatically fly to Mars, and hover over the night side of Mars, reflect sunlight back onto the Martian surface to warm it up. What is even more ingenious is, these solar sails can be produced directly using equipment from smartphone factories. Each solar sail requires sensors, cameras, communication modules, and control chips. Essentially, it is a space-use smartphone. Add a 2-pound reflective film, which, when unfolded, is as large as 2 basketball courts, and they become the core units of the Mars warming project. Handemer himself admits that even with massive investment, this plan could only raise Mars' temperature by about 1%. In other words, it can't truly achieve terraforming, but at least it can lay the groundwork for larger-scale transformation. The problem is, the available carbon dioxide and water resources on Mars are far less abundant than we imagined. Even if you use the most radical methods, like Musk's nukes or Handemer's solar sails, at most, this would only raise Mars' atmospheric pressure to 1% to 5% of Earth's. That is still several orders of magnitude away from an environment humans could survive in. An even trickier issue is water. Water on Mars is not only scarce, but also highly saline. These salts are different from those on Earth and contain large amounts of compounds that are toxic to humans. Drinking it is not drinking water, it is an invitation to death, of course. Theoretically speaking, this water can be purified using filtration and ultraviolet sterilization technology, but that means every astronaut has to carry a complete portable water treatment plant at all times, and that does not even include the constant risk of contamination from local Martian microorganisms. In other words, even if we managed to turn Mars into a semi-habitable planet, it would still require massive technological support and intensive life support systems, as well as extremely high maintenance costs. And the most crucial question is, should we really do this? There truly is some form of native life on Mars. Even if it is just the faintest bacteria, our act of transformation could wipe out an entire biological system. Are we here to save humanity or to destroy another world? This is something we must consider before we begin terraforming Mars. First, think calmly. To be honest, almost everyone wants to visit Mars. Now scientists are seriously studying if one day humans really settle on Mars, could the natural caves on Mars become our home? Mars is actually somewhat similar to Earth, although it is smaller than Earth, but the time it takes to complete one rotation is about the same. It is almost a day. By this logic, it actually seems more suitable than other planets in the solar system to become our second home. But there are quite a few problems. The first is temperature. Do not be fooled by its red appearance. Mars is not a hot planet. Quite the opposite. It is incredibly cold. Even though its surface looks like a burning red desert, its average temperature is actually lower than Antarctica's. On top of that, there is almost no atmosphere to retain heat and no magnetic field for protection. Mars has become a cold and barren planet. It even has the tallest mountain in the entire solar system. So now, scientists and astronauts are seriously considering whether we could live in Mars' natural caves. It might sound a bit far-fetched, but if you think about it, it actually makes a lot of sense. After all, our ancestors started out living in caves. Caves can block wind, keep out the cold, shield us from radiation, and protect us from dust storms. In the past, humans used caves to guard against wild animals. What we have to guard against now are solar winds, cosmic rays, and nights that drop to dozens of degrees below zero. Caves are no longer just a fallback for primitive humans, but could become shelters for modern civilization. More importantly, living in caves can save money. Building a structure that can withstand Mars' extreme environment is insanely expensive. Instead of struggling to build on open ground, why not make the cave itself part of the design? This will fundamentally change the way we build on Mars. It will also greatly reduce the overall cost of constructing the colony. And that is just the surface. Scientists are not only looking for caves on mountainsides, they are also searching for natural cavities buried beneath the surface. Some of these caves are as large as a football field. At least 9 such candidate sites have already been confirmed. These are all potential footholds for future colonization. So what would life be like if we actually lived in caves on Mars? First of all, sunlight would become extremely scarce, but we would arrive with advanced technology, not just to survive, but to establish a complete living system. Deep inside the cave, artificial systems would supply oxygen, regulate temperature, and maintain humidity. You could take off your spacesuit and move around freely. Just like you would on Earth, you only need to wear protective gear when you leave the cave. That is when you face the extreme environment outside. These underground bases are more than just shelters. They will have dormitories, recreation areas, supermarkets, and schools, even small hospitals and laboratories. There will also be indoor farms for growing vegetables and raising livestock to solve food problems. Blueprints for the designs already exist. Young people can choose compact studio apartments. Families have spacious homes, and there are luxury suites for the wealthy. Some buildings will be constructed inside caves. Others will be large dumb structures embedded in the Martian surface. Thick glass shields residents from radiation. At the same time, smart systems adjust the lighting. You can use virtual windows to change the view at any time. Maybe today you want to see a Martian sunrise. Tomorrow I want to see the Earth forest. Which with one click. Each residence is equipped with a passage leading to an enclosed driveway. It is convenient to commute or visit other cave settlements using special vehicles. We also do not have to do everything by hand. Most dangerous tasks will be handled by robots. Some of these robots look human, while others do not need to at all. They take care of construction, maintenance, patrol, surveillance, and even planting and transportation. And in the early stages of colonization, humanoid robots will land first, acting as stand-ins to simulate problems humans might face. The core of the entire Mars colonization system, besides construction and transportation, is artificial intelligence will control all life support systems. If any issue arises somewhere, it will intervene, diagnose, and repair it immediately, and notify humans. It will also be responsible for overseeing colonial order and even mediating conflicts, maintaining stability in this new society. But the real challenge is not construction. It is the arrival of the first humans. The first generation of residents on Mars won't be ordinary people. They will be a group willing to sacrifice for future generations. They will personally build the first school, hospital, greenhouse, and power station. They are pioneers, the creators of Martian civilization. But scientists alone are not enough. We also need doctors, farmers, engineers, and teachers, as well as musicians, chefs, and psychologists. Human civilization is built on diversity, and so must Martian civilization be. Once the colony is basically established and the systems are stable, it will be time for ordinary people. They will come with hope, with dreams, and with their own problems. They will become the true protagonists of life on Mars. Who knows? Maybe one day, we really will build artificial beaches on Mars to simulate beach life on Earth. Maybe there really will be a zoo on Mars, where we watch the animals brought there thrive once again and redefine this planet. In fact, the plan for humans to land on Mars is moving much faster than you might think. And who knows? Maybe the first person to sign up will be you. By then, you might even have your own little house on Mars. On this vast red wilderness, you could start a new life far from Earth. After all this daydreaming, let us get back to reality. Mars always seems to have new surprises in store for us. One moment there is a spoon. Suddenly something pops out the door. There is also noodles, jam rings, and even a human face. But are these bizarre things really just rocks? Recently, NASA's Curiosity rover captured another object on Mars that looks especially like a spoon. As soon as it was released, it sparked heated discussion. That rock appears to have a slender handle. The top is also rounded. It is like a smooth spoon floating in the air. The internet exploded instantly. Some people said it was an alien shoehorn. Others joked that Martians use it for bowling. But NASA scientist Andrew Good responded, "Do not get too excited. It is just an ordinary rock shaped by weathering and erosion. These strange rocks on Mars are formed by long-term wind abrasion. There is a scientific name for it. It is called ventifact. In fact, there are many similar wind-formed landforms in Earth's deserts. For example, the mushroom rocks in Egypt's White Desert are shaped because the wind erodes the base faster than the top. Over time, they end up standing in the sand like mushrooms. But the strange rocks on Mars are not just bizarre in shape. For example, Curiosity also captured a row of slender, sharp, alien nails near the Gale crater, sticking up from the ground like some kind of doorknob. These are actually yardang structures. They form when a hard rock layer covers a softer rock layer. Over time, the softer layer underneath weathers away, leaving the harder parts standing alone, like rows of fossil nails. Similar landforms are also common on Earth. For example, the Ferry chimneys in Utah and Bryce Canyon. These structures are very important to NASA because they can help study the ancient sedimentary rock history on Mars and its geological evolution. There is also a more famous peculiar rock. A few years ago, it went viral online. The Jelly Donut Rock. NASA named it Pinnacle Island. Strangely enough, it suddenly appeared on the ground in front of Opportunity. Just a few days earlier, there was nothing at that spot. It turned out, this donut was actually accidentally kicked over by the rover's wheels. But that does not mean it is worthless. Scientists analyzed its chemical composition and found it was rich in sulfur and manganese. These two elements are usually closely associated with the presence of water. This suggests it may have been eroded by water for a long time. Even more dramatically, this incident triggered a lawsuit against NASA. Some researchers argued this could be a fungus on Mars, and you did not investigate it seriously. As a result, donut fungus once became a trending search term worldwide. However, not all bizarre objects are the result of natural wind erosion. For example, Perseverance once captured a tangled mess that looked like Martian noodles. It suddenly appeared in a photo and then mysteriously disappeared a few days later. NASA believes that this might be a fragment of a thermal blanket left behind during Perseverance's landing. This material is called dacron, It is easy to tear and tangle in high-temperature and high-pressure environments. It looks like a bunch of chewed-up noodles. In fact, quite a few things were lost during Perseverance's landing. It was a piece of metal film that was also photographed stuck to a rock. It is suspected to be thermal armor that fell off during landing. What is even more surprising is some debris has already drifted as far as 1.2 miles away. NASA speculates that these fragments were flung away by the impact of landing and then blown further by the strong Martian winds. The winds on Mars are indeed very powerful, and these remnants from Earth have unexpectedly become specimens for studying the Martian environment. Although this space junk seems quite interesting, it has also raised a number of concerns. The garbage problem on Earth has not even been solved yet, and now humans have started polluting Mars as well. At present, these fallen fragments are gradually accumulating in an area called Hogwallow Hollow, forming a cluster. What is even more concerning is that these fragments could even end up inside the test tubes used to collect Martian rock samples, interfering with scientific experiments, contaminating critical data. Although NASA says there is no need to be overly concerned at this point, they have already started closely monitoring these situations to prevent them from having a substantial impact on future exploration missions.